So, ladies and gentlemen, good afternoon. So, today we want to introduce a new topic, which is tripods, right? Remember, I requested you to bring your pair of compasses. All right, I'll start by explaining what is a tripod, right? So a tripod is a type of a crane, right? I'm saying crane. It is a type of a crane that we use. It can be either at a construction site to lift heavy materials. It can be bag of cement or any other heavy material, right? So what type of equipment is a tripod? A tripod is made up of 3 legs, right? As the name is saying on its own, tri, it means 3, isn't it? So it is made up of 3 legs. I'll just try to illustrate here. So 1, 2, say 3. So this can be poles, steel poles, or it can be even be wooden poles. So 1, 2, 3 legs, they form a triangular base, right? So this is the base being formed by the tripod. So in most cases, 2 of the legs of a tripod, they will be equal, right? And then the 3rd leg can be shorter or a bit longer as compared to those other 2 legs, all right? So in that case, the triangular base that is going to be formed will be an isosceles triangle. So it's not always the case that we are saying that 2 legs are equal, then we have 1 shorter or longer. We can also have a situation whereby we are having all of the legs that are equal. All right? So before we can even deal with any calculations regarding tripods, I would like to show you a video of a tripod. A video of a tripod in a practical way. So basically that was a tripod. So what mechanism do we use? A tripod, when it is lifting a load, right? The load is lifted inside the triangular base that is being formed here, right? So what we do? We can connect a mechanism here. It can be a chain block, right? That we can use. Then we can lift our load, all right? So when it comes to calculations, there I think I put there on the screen a typical question regarding a tripod. All right, what are you required to do is, given any scenario, maybe you are given the length of the legs. We'll go back to the question, but we want to find the forces in each and every leg. All right, if probably we are given a scenario that a load of 40 kilonewtons is to be lifted, all right? So how strong should our legs be, all right? So now let's go to the question then. It says, a tripod has two of its legs measuring 4.9. Sorry for that. Two legs, 2.9. Sorry, 4.9. And it goes on to say the third leg is 5.5. So third leg is equal to 5.5 meters. The question goes on to explain that the legs form an isosceles triangle having a base of 3.7. Alright? The legs form an isosceles triangle having a base. So I'll say the baseline is equals to 3.7. 3.7 meters. Determine the forces in the legs when a load of 40 kilonewtons is suspended from the apex. Alright? Those are the scales that you are supposed to use. So the load is equals to 40 kilonewtons. Scales, we start with the linear scale, is equals to 1 centimeter, representing 1 meter. And then we are also given a force scale, which is equals to 1 centimeter, representing 20 kilonewtons, right? So I want to show that information as well here, right? This is our load, isn't it? So this is what we are saying is 40 kilonewtons, all right? We have two legs that are measuring 4.9. The third leg, which is the longest, is measuring 5.5, all right? So I'll say this is 5.5, all right? So the base that is being formed, it is 3.7. So I'll believe I'm having 3.7 here, all right? It's fine now. Now we have to determine the magnitude in those three legs. Where do we start? So the first step is for you to create the baseline. I will just lift my projector up so that I want to use this space here to do the construction. This is some information that I didn't put there. We say 3.7, that's the base, right? And the other side of the base is measuring 4.3. You find that information there on the board. Now, I said you start with the baseline. Which is 3.7, right? So I'll put 3.7 here. There is 3.7. Let me use a black ink. Don't forget that we are using a scale to draw that line, right? 3.7, the scale is 1 centimeter, 1 meter, right? So 3.7 meters would be how many millimeters on paper? 37. Right, 37 millimeters. So So we are saying 3.7 meters. So this is A, B. So the next step now is to draw the other side of the triangular base, 4.3, 4.3. So you can do this using your ruler and a pair of compasses only. Quite easy. Take your ruler. Now measure 4.3. 4.3 will give you 43 millimeters, right? Okay. So I'll probably put my 43 millimeters representing 4.3. Right. There you go. At A, you subscribe in up. You don't change the radius. This is still 4.3. At B, you subscribe in arcs. Sorry, I'll recheck that one. There you go. Now you've produced point C. Right, so this is the base. Alright? Right. What will be the next step for you to do? You go back to the question. I'm sure I managed to put all the information here so that it's easy for us. Is I'll just take off this one for now. Right, to the right hand side of this triangle, which is the base that is being formed, we have true length of two of the legs that are measured at 4.9, right? Okay, now we want to put the true length of those two legs. So you take your ruler again, measure a distance of 49 millimeters. That will be representing obviously 4.9 meters, right? Don't forget we say the two of the legs, they are equal, right? From the base we go to the legs, 4.9. With center B, you subscribe and up. This is 4.9. With center A, you subscribe and up. So let's give that point of intersection a name. Let's call it point O. So you join O to B, you also join O to A. After that, just join those 2 points, or to C, you can just use a dashed line, or a broken line. Right, so we say this is the true length of two of those legs that are equal, measuring 4.9 meters. So whatever that we've projected here is the floor plan of the tripod, right? This is the floor plan of the tripod. Now we want to work on the elevation, right? Which is a side view of the tripod. So what we have to do from the floor plan, just leave a considerable amount of distance, right? You really don't need to measure it. So just put a horizontal line on top. Is it horizontal? I'm afar. Horizontal line. Okay. From that horizontal line, I would like you to project point C. When you project, it means you're making a vertical line. Let me use a green color for my projections. From C, you project upwards so that you can get a point that you call C1. From B and A, they are on the same plane. You can also project going up so that you get A1, B1. You go to O, You also project it going up so that you can get point O1. That is clear, right? So we say C1, A1, B1, we have point O1. So what will be the next stage from there? Now with point A1 and the radius A1 to O1. So when I say that, it means you put the pointed part of your compass here, and this distance A1 to O1 here, you subscribe an arc above like that. All right. The next stage, what you are going to do now, because we want now to show the third leg of the tripod, which is measuring 5.5. All right. Take your ruler and please measure 5.5. 5.5 will give you 55 millimeters. That's correct, right? According to our scale. So get your 5.5. Now, with that 5.5, which is 55 millimeters, right? You go to center C1 here, all right? 5.5 is the third leg of our tripod. Actually, we have two legs that are equal. And we said we have one other leg that is longer, which is measured to 5.5, all right? Don't forget, this is the base that is being formed. All right, so with point C1 and your radius 5.5, subscribe an arc. Okay, subscribe an arc, and you're gonna get point O. You are going to get point O. Point O is the apex of our tripod. That's where we are going to connect our chain block, which is the lifting mechanism that we are going to use. I want to simply adjust. Remember here I'm not using a scale, so you might see that what you do have on your paper might be slightly different with what I'm doing on the board. So I just want to adjust. I think my 5.5 was a bit too big. Alright, let me just bring it here. So my O is here, I just shifted. Alright, so now you take O, you join O to A1 and B1 with that line. After that, we also have to join O to C1 like this, right? So we are saying this is the third leg, which is 5.5 meters. All right. Now, what will be the next stage? Now we are going to the loading, to the load that has to be lifted by the tripod. And what is the load? The magnitude of the load, we say it is 40 kilonewton, right? And you are required to use a scale, 1 centimeter, 20 kilonewton, right? So you come to O, you drop a line, right? That line is our 40 kilonewton. So how long is that line going to be? If we are using a scale 1 centimeter, 20 kilonewton. 2 centimeters, which is 20 millimeters, right? So you measure 20 millimeters, all right? That is the load, and you can call that point, you can call it any name you want. So I just want to call it P, point P, all right? Now, what we would like to do now is, with P, we want to create a parallelogram. Do you still remember the parallelogram of forces method, right? whereby we can get the resultant force of two given forces, right? We can also, from a given force, we can be able to find the components of that force, right? So we want to create a parallelogram. So what you are going to do, please make sure that you use your set squares. I think you know that that method, right? Right. So from P, I want to draw a line that is parallel to C1, right here. Then you come, okay? There you go. This line and this line, they are running parallel to each other. So you can call that point, let's call it N. All right, it's fine. From P again, we want to draw a line that is running parallel to this one. All right, then we come. Now you see we have created a parallelogram there. So you can call that name, that point you can call it M. All right. Already here we've solved one of the problems. We have the magnitude in the third leg, right? This is the third leg, which is OC, right? So the magnitude of OC is equals to OM, right? So what you are going to do, for you to get the magnitude, you are simply going to measure the line OM, right? And check how many millimeters are you going to get. Then you go back to your scale, right? And you get the kilonewtons, right? I think if you can do your things properly, you are going to realize that OM will give you plus or minus 10 kilonewtons. That is the force in the third leg, right? Now, what about these two legs, right? With those two legs, what you are simply going to do is, I would like you to transfer point N next downward. So what you are going to do with this center, right, and this radius, please subscribe and up. That is going down and it cuts the horizontal line. When it does that, please can you drop that point. You can call that point N1. Until this is N, let's simply call this point N1. So with N1, you drop again a line, drop it down, then you get this point. You simply have transferred N to the floor plane, right? So now we have N here, right? So whatever that you did here, you are going to do it here again, right? Whatever that you've done here, you've created a parallelogram, right? I want you to create another parallelogram on the floor plane, all right? With point O, a line that is parallel to AO. There you go. Fine. With the same point again, a line parallel to OB. There you go. Then you can name that parallelogram. Probably you can say this is T at this point. This is S, all right? Now I think we are done. So what does it mean here? The leg OB weighs OT. That is the force. So you are simply going to measure the length of OT, check how many millimeters, go back to your scale, and check how many millimeters are you going to get. So I said, if you have been working on your scale properly, you are going to realize that here you will get probably plus or minus 18 kilonewtons, right? So you realize also this is the same length again. So on leg OM, A is equals to OS. Alright? You measure the line, and I believe you are going to get the same length, right? And if you've done your work carefully, you get plus or minus 18 kilonewtons. So that is all about the tripod. The next class we are going to do a shear leg, more or less similar, but when you move on to a shear leg, right? A shear leg is having two legs that are equal, right? But the third leg is very long, and we call it a backstay, all right? Right, so I'm just going to illustrate what I'm trying to explain here. So it is something like this, right? It forms a base as well, but this one is a backstay. And when you lift the load is being lifted outside the triangular base that is being formed, right? So our load will be outside. Okay, ladies and gentlemen, thank you.